Alright, in Trig we are on 1.6.
1, 2, 3, 4.
And that is inequalities. So let's take a look at these different kinds of inequalities in 1.6. As you know, there are expressions that contain this is less than, this is greater than, this is less than or equal to, and this is greater than or equal to, which we all know those by now. But we discussed this in the prereq section, and we're discussing it again, that new notation that you need to write these in. So we're just going to skim through this quick. If you remember, these parentheses, these curved brackets here, stand for less than or greater than signs. And this is kind of like a sandwich problem, right? This curve goes with this sign, this curve goes with this sign. And remember, when we are graphing those are open holes at both A and B. In number 2, the square brackets, those are less than or equal to or greater than or equal to signs. Okay, once again, this is like a sandwich problem, meaning it goes from A to B, and it's a closed hole that we're filling in there. So once again, something to keep in mind. You can also have it closed on one side and open on the other, which means if it's closed, it has the bar underneath it, so it's a less than sign here, and it is less than or equal to here, and just a less than sign on that side. So you can have it closed on one side and open on another in an interval. And you can have it open on the other side and closed on the other side. So this, we already went over this already, so this is review, even in the trig section. We went over it in the prereq. This sign right here stands for infinity. Infinity is always a curved bracket, always, because you never know when it's ending. Okay, so this is saying that it starts at A, and this is a greater than sign because it's everything from A the whole way up to infinity. And whenever you write intervals, it's always the lowest number to the highest number. That's how you always write them, from low to high, low to high. So low meaning this number is something less than infinity. You have no idea what it is, but it's something less than infinity. So at A, you put an open hole because it has a curve there, and it goes on forever in that direction to the right. This means you got a square bracket, which means it's actually touching the point at A, and it goes on forever to the right. So continuing the notation as well, this is saying that it goes on forever in the negative infinity direction. This is just telling you which direction, so that means all down here. So B is some number higher than negative infinity, and it is open hole because it is a curved bracket there, and it goes the whole way down and to the left. And this is the same exact problem, except it is a closed hole at B because it's less than or equal to, so that's why it's a closed hole at B. And 9, this is just saying that it goes from negative infinity to infinity, which means all real numbers. Basically, the whole line should be shaded in. Properties of inequalities. If A is less than B and B is less than C, then A is less than C. Okay, so if 2 is less than 5 and 5 is less than 9, then 2 is less than 9. Yes, we know this is the transitive property. If A is less than B and A plus C is less than B plus C, then A minus C is less than B minus C. So how does that work? 2 is less than 7, right? So then 2 plus 3 has to be less than 7 plus 3, which is correct. That's 5. It's less than 10. So then 2 minus 3 has to be less than 7 minus 3. So a negative 1 and a 4. Well, there it is. That's correct. If A is less than B and C is greater than 0, then A times C is less than B times C. So let's see what happens there. I have no idea what's going on. Okay, I guess somehow that one leaped over there. If A is less than B and C is less than B, then A times C is less than B times C. Okay, so that's what we have right there. And I believe that was supposed to go there. So 2 times negative 3, 5 times negative 3, right? So that's a negative 6, and that is greater than negative 15, so that is true. 2 divided by negative 3 is greater than 5 divided by negative 3. That is also true. So just things to keep in mind. So, solving regular old inequalities, minus 4 on both sides. It's just like solving equations. Except the only little trick here to remember is whenever you divide by a negative, who remembers what you're supposed to do? You're supposed to flip the sign. So it's x is greater than 7 over negative 3, because we got to flip that sign. Remember to flip that sign when you divide by a negative.
I've fallen for you like a blind roofer.
So, solving this one, I like to keep things positive if at all possible, so I'm going to move that over this side. That will give me 4x is less than 2x plus 8. And if I move that 2 over there, that's 4 minus 2, so that's 2x is less than 8. So I divide by a positive 2, which means there's no flipping of any signs. So I get x is less than 4 as my answer.
Is this your final answer?
So example 3, when it's a sandwich problem like this, you do the same thing on all sides. So I'm going to add 4, which means I have to add 4 everywhere. Negative 6 plus 4 is 2. I have a 2x in the middle, and 2 plus 4 is 6. I'm going to divide by 2, which to get rid of to get x by itself, which means I have to divide everything by 2. So negative 2 divided by 2 is negative 1, and 6 divided by 2 is 3. So this is negative 1 is less than x is less than 3.
It is the year 2000. It is the year 2000. But where are the flying cars? I was promised flying cars.
Alright, this is divided by 2, so I'm going to multiply both sides by 2 to get rid of that 2 on the bottom. So I get a negative 10 is less than or equal to 4 minus 3x, which is less than or equal to 2, because 2 times negative 5 is negative 10. 1 times 2 is 2. So I'm minus 4, which means I have to minus 4 on all sides, so I get negative 14 is less than or equal to negative 3x, which is less than or equal to negative 2. And I divide by a negative 3, which means I have to divide everything by a negative 3. And because I'm dividing by a negative, I need to flip the signs. So this is a negative 14 divided by negative 3, but notice how the sign flipped. So the negative 2 divided by negative 3, notice how the sign flipped. And those negatives, because it's a negative divided by a negative, they're actually positives. Now you always write from low to high. This is the lower number, which means I need to take the whole item and flip it over. So it's actually 2/3 is less than or equal to x, which is less than or equal to 14 over 3. This sign, it should actually have the bar under here. Okay, so keep that in mind. There's no bar here. There should be a bar right under here, though. So it's less than, and then this one is less than or equal to. Because you just flip them right over.
Jump, Free Willy! Jump!
Okay, and then a problem like this. How can we get this to be 0? Well, if we were to try to solve this, you'd multiply by x minus 2 on both sides. Well, what's 0 times x minus 2? It's just 0. So really, what we're saying is 1's greater than 0. So the point we're getting at is anything can work to plug in there besides one number. And that number is 2. It can't be a 2 because if we have a 2 in the bottom, it's undefined. But hypothetically speaking, we have to figure out what can and cannot work. Well, I know for a fact 2 can't work. We tried to solve this, but nothing came from it. So a 2 can't work. If I plug in negatives underneath there, I end up with negative numbers which aren't greater than 0, so they don't work. So basically what we're saying is the number has to be a positive number that is greater than the number 2. Because if it's greater than 2, like a 3 or 4 or 5, then I get numbers that are all greater than 0. So it has to be a number that's greater than 2 in order to get the answer. So if x is greater than 2, then it will make sense and the statement will be true. So in that problem, we tried to solve it and we realized, wait, that doesn't work. Nothing works to solve it. So the only way to solve that problem was by plugging in numbers and kind of guessing and checking in a way to figure out what your answer was. So how would you write that? Well, you go from low to high, any number greater than 2. So 2 at the bottom, and then it goes on forever, which is why that's infinity right there.
Watch out for that first step. It's a doozy.
When we come back, we'll talk about union and